Alright, so I decided to make this a second video, so it's going to be page 2 of that review packet. So you can take this in stride. Alright, so here's what I like to do with these. I like to make individual fractions. So I'll put 4x cubed and 4x cubed. Hey, this is like the distributive property, where that 4x cubed has to go into every single factor. So I can go ahead and rewrite this as 4x to the 10th over 4x cubed plus 6x to the 6th over 4x cubed plus 8x cubed over 4x cubed. So here's the fun part. You get to cancel out any factor above and below the line. So for example, these x cubes cancel out with these x cubes, and 4 goes into 8 twice, so you know that your last term is going to be a plus 2. Alright, let's check out this. If I have 6 x's on top and 3 on the bottom, 3 of them are going to cancel out. So I know I'm going to be left with 3 x's. Let's talk about this fraction. If I take a 2 out of each, that's going to give me 3 halves as my coefficient. Alright, let's see what's over here. 10 x's up top, 3 down bottom. They're going to cancel out and leave me with 7 x's in the numerator only. My 4's cancel out. So here is my final answer using division. Now for this one, my 9x cubed y is going to be divided and distributed to each of these fractions. 9x cubed y, 9x cubed y. So when I go to divide, I have to look at the coefficients and each of the variables. So 9 into negative 18 goes negative 2 times. 3 x's down bottom, 12 up top, are going to leave me with 9 x's. 1 y and 4 up top are going to leave me with 3. Let's take a look at our next fraction. 9 goes into 27 3 times. 11 x's up top, 3 down bottom, leaves me with 8 x's. 2 y's up top, 1 on the bottom, leaves me with 1 y. Next fraction. 9 goes into negative 81, negative 9 times. 5 x's, 3 x's, going to leave me with 2. And 1 y and 1 y completely cancel out. Alright, let's move on. Now look, here we do have a fraction where we will have a denominator. If I divide a 3 out of each of those, I get the fraction 2/3. My x's completely cancel out, and I end up with 2 y's left over. That was a tricky one for sure. Alright, let's see. If x is not equal to 0, what is the quotient when the following divisions performed? Now what's interesting is if you remember long division from elementary school, you can go ahead and do that. If not, go ahead and rewrite the problem as a way that we understand. Because what you're going to do when you divide this whole thing by 2x is you're going to do the same thing that we've been doing. Divide each term by 2x. So 2 goes into 6 3 times. X goes into x cubed with 2 left over. This is a very important thing. Don't forget, when something goes into itself, it goes in one time. And notice they gave you a tricky one here. This is not the correct answer because they forgot that one. So this is a most missed too, because there you go. There's our right answer. All right. The figure above is composed of rectangles. Which expression represents a shaded area? Hey, these are tricky. X times x is going to be x squared. So this entire thing is x squared. But notice it says the shaded area. So what I want is this whole x squared except for this box here. So this box is 2 times 3, or it has an area of 6. I want the shaded area, which is the entire box of x squared minus that rectangle that I don't want. There's my right answer. Alright, so this one says check all of the expressions that are equivalent to this. Lord have mercy. So let's see. If we go and we multiply these together, 2x, let's try FOIL. This is going to give me 2x squared plus 8x minus 3x for my inner, and my last is minus 12. This gives me a 2x squared plus 5x minus 12, so no, because this is minus 5x. Okay, let's see, 4 plus positive 2 is going to give me 6x squared, and I know right away that's not going to be possible because I want 2x squared. Alright, let's share out this negative. Negative 4x squared, negative 14x, and negative 10. So when I add them together, 6x squared minus 4x squared is going to be 2x squared. Positive 9 and negative 14 is negative 5x. Negative 2 and negative 10 is negative 12. So, yep, that's a good one. Let's check out this one. 4x squared and 2x squared is 6x squared. So, guess what? No. This one's another no. Alright, let's look at this one. Multiply our first terms, 2x squared. Our outside terms, minus 8x. Our inside terms, plus 3x. And our last terms, minus 12. Guess what? 2x squared minus 5x minus 12. Good news. We found 2. Did you see that last part? There you go. Alright, let's look at 26. So I have an x squared, an x, and a 1, and it's shaded. So I want to know which model represents this. Guess what? I need to do some simplifying. So that's x minus 2 times x minus 2. Let's FOIL it. X times x, x squared. X times negative 2. Negative 2 times x, positive 4. So I have x squared minus 4x plus 4. So this is x squared 1, 2, 3, 4 plus 4x, and this is plus 4. This is x squared plus 4. This is x squared minus 4. So by process of elimination, let's take a good look at B. Here's my x squared. Here's minus 1, 2, 3, 4 x's, and here's plus 4. That looks like a good one. All right, let's check out the back. What is the value of this expression when x is equal to 3/5? All right, so if I have 3/5 squared minus 5 times 3/5 plus 1. So we take this value for x and we plug with a hug, substitute and simplify. So when I go to simplify, this gives me 9/25 minus 3, because these 5's cancel out, plus 1. So when I go to simplify that, I have 9 over 25 minus 3 plus 1. So you have a choice. You can get your calculator out or go to Desmos. We'll go ahead and clear that out. And I'll say 9 divided by 25 minus 3 plus 1. And we'll do math, frac, enter. Negative 41 over 25. Desmos or your calculator will help you get that answer faster. All right, which value of x will make this true? That's the same way as saying solve for x. Whenever you have proportions, remember that's cross products. So 3 times x minus 5 is going to be equal to 6 times 2x plus 1. We have to use the distributive property. Subtract 6 from each side, and I have negative 21. Subtract 3x from each side, and that's going to give me 9x. Divide by x, divide by 9. What am I doing? Divide by 9. X is going to be equal to, if I divide each of those by 3, negative 7 thirds. The graph of line N is shown. What is the slope and what is the y-intercept? So kind of hard to tell. This looks like 1, 2, 3, 4, 5. We'll go with 6 and we'll call this 1, 2, 3, 4, 5. You want to do that? So the x-intercept is going to be over 2 up 0. The y-intercept looks like it's over 0 up 6. And the slope is going to be our rise, 1, 2, 3, 4, 5, 6, over our run. So 6 over 2 is equal to 3. Those lines didn't show up very good, did they? All right, given the relation, list the domain and range in set builder notation. So my domain is going to be all my x's, and we can start here. All the values of x such that x is equal to negative 4, negative 2. Here's an x value of negative 4, an x value of negative 2. Here's an x value of 0 and an x value of 1. Our range is going to be where it touches our y-axis. So are the values of x such that x is equal to negative 2, positive 1, positive 2, positive 3. All right, list a value for x that would prevent the relation above from being a function. So if it's a function, there are no repeats in the domain. So if x were equal to 9, not a function, because prevent means make it not true. Or you could have said positive 5 or negative 1 or positive 1. Any of those will work out. All right, time to simplify the radical. I'm looking at a square root here. So when I'm looking at 200, that's 100 times 2. 100 is 10 times 10. So I know 10 is going to come out of the radical. There's my double factor. I have 10 a's, which means 5 of them will be able to come out. I have 13 b's, which means 6 will come out, and 1 is left behind with this 2. So square root of 2b is what's left. We're going to skip this one for now, and we're going to go ahead and solve for x. We're going to solve for x and combine like terms. So negative 4 is smaller than 2x plus 12. Subtract 12. And I'll say that 16 is smaller than 2x. Divide by 2. So I have negative 8 is smaller than x. Another way of writing that is going to be that x is greater than negative 8. If you're more comfortable with your x's on the left, you can do that way. All right, simplify. Assume the denominator is not equal to 0. So negative 8 goes into 56, negative 7 times. And guess what? We still have 6 a's on the bottom, and we have 3 b's up top. Given the system of equations, what is the value for x? This is a pretty good equation for substitution. So 2x plus, instead of y, I'm going to write what y is equal to. And for this case, y is equal to negative 4x plus 2. So that's going to be negative 2x plus 2 is equal to 10. Negative 2x is equal to 8. X is equal to negative 4. And that's all they asked for, so that's all I'm going to do. Okay, so this goes to our line of best fit. The number of complaints a company received at the end of 6 weeks is shown in the table. Based on the line of best fit, how many complaints should the company expect at the end of week 8? So let's see if we can logic this one. So here's 7 and here's 8. So all the numbers are decreasing. So all of these numbers are decreasing. So it's looking like we'll have to use the line of best fit. I hope you remember these steps. Are you ready? We're going to go ahead and go to Stat. And we're going to go to Edit. And we're going to enter in our weeks 1, 2, 3, 4, 5, and 6. Come on over here and enter in their data. 225, 205, 187, 169, 147, and 130. Now, if you went to go use Desmos, what you're going to do here with Desmos is you're going to enter into the table all of these values. And then you're going to go ahead and ask the Desmos to give you your y1 is sort of equal to mx1 plus b. Remember that? If you do that, it'll give you the line of best fit. Now with the calculator, we can go ahead and say stat, calc, linreg, and it tells us our equation. We have a slope of negative 19 and a y-intercept of 243. So if my slope is equal to negative 19 and my b is equal to 243, we can go back into your y is equal to equation, and we could say negative 19x plus 243 is our equation. Graph it. It's too high up for us to see, but we can go to the table of values, and we can see at the end of week 8, we have 91 complaints. Okay. I wouldn't worry too much about that one. Since we're not taking the SOL, you'll have lots of time before you ever have to pass that one on a test. Anyway, good job today. Talk to you soon.